Hello, it's Mrs. Laffey, and we're doing Unit 7, Lesson 16, Common Factors. So let's take a look at the warm-up, which is 16.1, and it says, how are the pairs of figures alike and how are they different? So I'm going to start with what's similar. Each pair has a yellow figure and a blue figure. Next, each figure is made of small squares. Next, all the yellow ones have 6 squares and all of the blue ones have 10 squares. And then I recorded some of the differences. So differences are some have rectangles. So you'll notice the first one are both rectangles, then there's rectangle and rectangle there. So some pairs have rectangles, some do not. Some have an L shape, like this one, this one, this one, this one. The heights go up by 1 each time, so the height of this one is 2, the height of this one is 3. Oops, sorry. This one is 4, and this one is 5. The first pair is the only one with 2 rectangles. All the other ones have a rectangle and an L shape. And the third pair has 2 L shapes and no rectangle. All right, going down to 16.2. Diego is preparing brownies and cookies for a bake sale. He would like to make equal bags for selling all of the 48 brownies and 64 cookies that he has. Organize your answer to each question so that it can be followed by others. How can Diego package all the 48 brownies so that each bag has the same number of them? How many bags can he make and how many brownies will be in each bag? Find all the possible ways he can to package the brownie. So we're just talking about brownies in this one. So he can do one bag with all 48 brownies, or 48 bags with one brownie. He can do 2 bags of 24 or 24 bags of 2, 3 bags of 16 or 16 bags of 3, 4 bags of 12 or 12 bags of 4, 6 bags of 8 or 8 bags of 6. Then we're going on to talk about the cookies in number 2. So then it says, how can Diego package all of the 64 cookies so that each bag has the same number of them? How many bags can he make? And how many cookies will be in each bag? Find all the possible ways to package the cookies. So he can do one bag with all 64 cookies, or 64 bags with one cookie. He can do 2 bags of 32 or 32 bags of 2. 4 bags with 16 or 16 bags of 4. And he can do 8 bags with 8 cookies. In number 3, it wants us to combine. So how can Diego package all the 48 brownies and 64 cookies so that each bag has the same combination of items? How many bags can he make and how many of each will be in each bag? Find all the possible ways to package both items. So he can do one bag with 48 brownies and 64 cookies. Or he could do 2 bags with 24 brownies and 32 cookies. 4 bags with 12 brownies and 16 cookies. Or 8 bags with 6 brownies and 8 cookies. Or 16 bags with 3 brownies and 4 cookies. So then it asks number 4, what is the largest number of combination of bags that Diego can make with no leftovers? Explain to your partner, which you can't do, how you know that it is the largest possible number of bags. So we showed all the different combinations, and the largest would be the last one, which is 16 bags with 3 brownies and 4 cookies. Okay, moving on to 16.3. Greatest common factor. So the greatest common factor of 30 and 18 is 6. What do you think the term greatest common factor means? The largest factor, so the answer to that is the largest factor that both numbers share. So if the factor are the numbers you multiplied to get that number. So if the factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6, and the factors of 18 are 1 and 18, 2 and 9, and 3 and 6. So if we're listing them, the factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. And the factors of 18 are 1, 2, 3, 6, 9, and 18. And the GCF is 6. So when I look up and do my upside down cake method that I showed you how to do in class, we start by putting the two numbers here, and then you divide by 2 until you can't divide by 2 anymore. So 30 divided by 2 is 15. 18 divided by 2 is 9. Now neither 9 nor 15 are divisible by 2, so I'm going to use 3. 15 divided by 3 is 5, and 9 divided by 3 is 3. And I can't go on anymore because these are prime numbers. So we have 5 and 3, they're only divisible by 1. So to get the GCF, you take the two numbers on the side here and you multiply them together. 2 times 3, which is 6, which is what we said our GCF was. So that's just a different method of finding it. But in here they want you to list them all, so you have to do it this way. So find all of the factors of 21 and 6, and then identify the greatest common factor of 21 and 6. So the factors of 21 are 1 times 21 and 3 times 7, and the factors of 6 are 1 and 6 and 2 and 3. I listed them over here, and the greatest common factor is 3. And then I also show how you would do that with upside down cake method, which is putting the two factors here. And neither 6 is divisible by 2, but 21 is not, so we need to use 3. And 21 divided by 3 is 7. 6 divided by 3 is 2. And these are both prime, so we don't go any further. So there's only one number here. You don't need to multiply it by anything, but the GCF is 3, which confirms what we had done over here. All right, number 3. We're doing 28 and 12, finding all the factors of 28 and 12. Then I'd identify the greatest common factor of 28 and 12. So I list them here. The factors of 28 are 1, 2, 4, 7, 14, and 28. Factors of 12 are 1, 2, 3, 4, 6, and 12. The greatest common factor is 4. So you see here 2 and 1 are also factors, but they are not the greatest factor. Then using upside down cake method, excuse me, I did 28 divided by 2 is 14, 12 divided by 2 is 6, and then 14 divided by 2 is 7, 6 divided by 2 is 3. These are both prime, so we can stop there. 2 times 2 is 4, and that confirms our GCF of 4 here. So you don't have to use both ways. I'm just showing you two different ways. All right, number 4 says a rectangle bulletin board is 12 inches tall and 27 inches wide. Elena plans to cover it with squares of colored paper that are the same size. The paper squares come in different sizes. All of them have whole number inches for their side lengths. What is the length of the largest square that Elena could use to cover the bulletin board completely without gaps and overlaps? Explain or show your reasoning. So, I made a little graphic here to show my 12 inches by 27 inches. And if I use the greatest common factor of those two numbers is 3, so I can make each square 3 by 3. 12 is divisible by 3, and so is 27. And that would be 3, 6, 9, 12. And then over here, I would have 9 threes. So there would be 4 squares by 9 squares. B asks, how is the solution to the problem related to the greatest common factor? And the answer to that is the two sides must be divisible by both 12 and 27. So the side length is a common factor of 12 and 27. So the side length of the largest square is going to be 3 because that is the GCF. Okay, and that's the last question for this unit. You need to do your practice problems in Unit 16, correct them tomorrow with the video that comes out tomorrow, and then do the cool down in Google Classroom. All right, have a great day, guys.